today's video, we will learn all about the Singleton design pattern, part of the creational design patterns. We'll be focusing today on the implementation for C++. We'll learn about what is the Singleton design pattern and when we should use it. As well, we'll go over the 4 common ways of implementing it, and the last one will be the best way with only two lines of code that's required to implement a full Singleton design pattern. Now, if you already know what that is, please leave a comment and put a like on the video, and let's get started. So, what is the intent for the Singleton design pattern? Is to ensure that a class has only one instance while providing a global view. What really that means? We just want one view, only one for the whole global. This comes in cases like using file systems, database connections, device drivers where you can only access one, and you want to ensure that there's only one objects for it. This implements kind of the lazy loading method, what everybody refers to. It's when first time you access it, and then it will create the object, and then you'll be able to load it into memory. So it's really good efficiency on that. As well, it provides a full global coverage. The mechanisms really, you just need to create a private constructor, have a static member function to get the instance of it, as well your instance variable for the needs to be static and private. Oh, whoa! Before we jump there, we got UML. Oh my god! If you don't know what UML is, it allows you to high-level describe class in an object-oriented in a unified markup language. Here is the most simplest human drawing for the singleton. You have the instance, creates a singleton, and loops back to itself and gives you a publicly accessed method through all the 4 different common implementations of singleton. We'll walk through the basics to the most used and the most effective one that is only 2 lines of code. All this code will be posted on the Git Hub repo, so please make sure to check it out and like it, as well as make sure you like the video and comment on anything that should be posted. So let's go walk through it. So the first one we're starting off with is the simplest class, which is probably something you got taught at school, in a sense where you need to create a static member of which will be returning the instance, and the return is of the singleton class, which is a pointer. So it's pretty straightforward. We're checking if it's null. If it is null, we're gonna create it and then return a reference to pointer to it. One of the things to note that's required is you're gonna need to create a static variable over it, as well as the key is making sure that protect that constructor and make it private for it. I also have here additional boilerplate code for just standard making sure no copy moves or assignments operator. As well, for the test, we got 2 threads that should return 1 and 2 if executed correctly. Now, this piece of code, one of the main thing is this is not thread safe. So you can actually create 2 instances of a singleton potentially. So let's check it out. I am using 14 to compile here, and I'm just gonna copy and paste the lines, and let's execute, and we should be able to see the output pretty quickly. As you see, it gives us 1 and 2 as expected, but if I run it a couple times, as you see, we'll get 1 and 1. And that means to create 2 instances of the singleton instead of 1. So it's not the most efficient. It is the most simplest to understand and get started. If you have a single thread application, it's fine. But for multi-threaded, we need to use something like the double check locking. This method is a little bit more advanced, but it is thread safe. And the big difference here is that when we do check for null, we're going to take a mutex lock. We're going to then check one more time, because when you're taking that lock, you can still have a potential issue. But once the lock is grabbed, we'll just double check that it hasn't been created. If it hasn't, then we're going to create that new instance of the class and return it. The secret to it is actually you need to have it to be atomic variable and support that without the atomic, this does not work properly to be able to take that the guarantee of being thread safe. So with that minor change, let's take a look how it results, and this should be all thread safe, so we should see any issues going forward with the results. So as we can see, 1 and 2, 1 and 2, 1 and 2. It's pretty clear for it, but it's a little bit, I don't like doing the double checking. Personally, there is a much more elegant solution, which is even a little bit better. It utilizes the standard library call once function. This function guarantees that inside of it will be call once. The flag will be set correctly to the once flag std variable, as well as it's much cleaner. We're using a unique pointer, which will have auto cleanup, and it's just overall, instead of dealing with pointer, we're now dealing with references. As you can see, we're returning a reference. On the static, it's just an overall cleaner, nicer instance of implementation of a singleton. So let's take a look at the implementation here. I just gotta correct the name. All right, we got it compiled. Let's check it out. As expected, there are no issues with it. Bit clean, a little bit cleaner, but it's still not the best. The best method gets even much easier for the implementation of the singleton, and we're gonna show you first. And the big difference, it's now 2 lines, as I said, and it's using the static keywords. With the modern compilers, the static now has a special functionality that allows you and guarantees you thread safe initialization once through it. So all you have to do is create a static variable of that class, singleton, and then we're going to take it and return a reference to it. And I got the spelling correction, so let's just correct that, and then we're just gonna save that. And as you saw, we got rid of it's just boilerplate code left through it, and it's the same execution for it. So let's take a look. And obviously sometimes the printout might be slightly different, but it is always 1 and 2. So thank you for watching. Please comment and subscribe and like. It helps out the channel to keep delivering more content. So thank you.